Hey everybody, I'm probably on my way to sunny California. Sorry, don't want to rub it in, but today let's talk about ratios. So ratios, oops, I think I'm on the wrong side. I am, there you go, ratios, and how to solve them. So hopefully in your reading you read a little bit about ratios. And what I have here is a ratio equal to a ratio. Well, it's a fraction equal to a fraction. And I want to do is solve for it. So if it's just a fraction equal to a fraction, I'm going to do a little trick called cross multiply. Cross multiply. So when I cross multiply, I take the bottom of one of the fractions and multiply it up to the other side. I'll take the bottom of the other fraction and multiply it up to the other side. So I'll just do this. I'm going to bring the 9 up over here. The 9 is going to be multiplied times the x plus 3. And I'll take the 45 and I'll multiply it up times the 4. So I'll go 4 times my 45. Alright, so then all I have to do is just multiply that out. 4 times 45, I guess it must be 180, but I'm going to double check on my calculator. 4 times 45, yeah, 180. Equals 9x plus 27, right? And I'll keep solving because I distributed. Minus 27, minus 27. I get 153 equals 9x. Divide by 9. Divide by 9, divide by 9, and x is 17. Okay, that's not too bad. All right, next example. Let's take a look at example 2. So example 2, what we're looking for are words. Words are the key in this whole thing. We got to keep the words consistent. So let's write that down. Words. What am I talking about? Well, let's read it, okay? The college brochure states that 15% of students attending college are majoring in engineering. If 2,400 students are attending the college, how many major in engineering? So the words I think I'm looking for are things like students, right? I've got students, and then I've got engineering students. So I've got engineering, and I've got engineering. Okay, so let's see if I can set up kind of a little ratio here. So I'm thinking, all right, let's make sure that we have things consistent. So what I have is 11.5% of the students attending the college are majoring in engineering. Okay, there's 240 students. So let's set it up as this. We're going to have our students, and we're going to have our percentage, right? Has to equal some answer in terms as a percentage. And again, if we're looking for 100% of our students, right, then we have to go ahead and put that down as 100% of our students, 100% of our students. So I'm going to go and set this up as, I'm not sure, I know that I'm going to go x, which I don't know. That's what I'm looking for. So I'm going to go the x amount of students, the percentage of students out of my 2,400 has to equal my 11.5% out of my 100. So the reason this works is because 100% of the students is the 2,400. That's all of my students. That goes with my 100% there. I'm looking for so many students that make up the 11.5%. Okay, same thing as I did last time. I'm just going to cross multiply and solve. So I go this times this, cross multiplication, multiply this times this, and this times this. So I'm going to go and make a 2,400 times 11.5 is equal to 100x. Okay, cross multiply. Yeah, there's another way to do this. I understand that, but I'm just doing it this way. Okay, so then I'm going to multiply 2,400 times my 11.5, and I get an answer of 27,600 equals 100x. Divide by 100. That's pretty easy to do. Just take out two zeros. And I get 276. So what is that? Those are the students that are in engineering. So this engineering students. Okay? So when I do these, I really try and set up the right words. Let's look at the next one. Alright? So a pedometer measures how far a jogger has to run. To set a pedometer, Rita must know her stride length. Rita counts 3 328 strides as she runs once around a 400-meter track. Okay, so there's some words. I got meters, I got strides, okay, I got meters, and I got strides, okay. And I think that we're talking about a meter is about 39.37 inches, okay. So what I have to do first is, let's see if I can make a little conversion. Let's see if I can solve for this. So I've got a 400-meter track, 400-meter track. She does 328 strides, right? And we want to know how many meters is one stride. And then we'll convert it to inches, okay? Is equal to one stride, okay? So if I just divide the 400 by the 328, which I'm going to do, so I'm going to go 400 divided by 328, I get an answer about 1.22. So we'll round to 1.22 meters per stride. All right, think about that. It's a little bit over a yard. She's running pretty fast. That's how long one stride is. Okay, now how many inches is that? We'll use our conversion. So we'll take our 1.22. We'll multiply it times our conversion, which is our 39.37. So you know the people who don't know anything about meters can understand it. So I'll go 1.22 times my 39.37, and I get an answer about 48 inches is their stride length, or 1.22 meters, right? I mean, if you're European, you're going to like the 1.22 meters. If you're an American, you've got to use inches. Okay, let's turn the page. All right, this is where I tried to start, but obviously, you know. So this looks like a geometry lesson. I think we did do this in geometry. So let's go ahead and try and set it up to similar triangles. We did this last year in geometry. So triangle ABC has vertices at 0, 0. All right. 8, 4. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. There's my B. And at 8, 0. There's C. Okay. So let's draw it in. All right, here's my triangle ABC. I'll put in blue. There it is. Now, it says that it's similar to another triangle with vertex at 2, 0. Okay, so I'll put in the vertex at 2, 0. That's right there. So that means there's a little itty bitty triangle here in red. Okay, so what we want to do is find the other points. Well, I pretty much have it by graphing. You agree? We could set up a similar triangle. We can go this length to this length would equal this length to this length, which I will do, okay? I could say this length, which is 8, over this little length, which is 2, has to equal, what else do we know? We know this length, which is 4, over the little length, which we'll call x. Okay, obviously, if you solve for this, you should get 8x equals 8 and x equals 1. Now, of course, so if x is 1, you know that this value is going to be at the point 8 to 2, 4 to x. So this length is 1. We know that's 1. We already knew that our coordinate was at 0, at 2, 0, and this one's at 2, 1. How's that? Not too hard. You guys did this in geometry. Last example, example 5. Okay, a rock climber wants to know the height of a cliff. The climber measures a 4-foot shadow of a 5-foot friend and measures the shadow of the cliff is 60 feet. So let's draw a picture. So here's the friend. He's just kind of hanging out, right? And he's got a shadow that he casts. So his shadow's here is 4 feet, right? He happens to be 5 feet tall. Okay, then he's looking up at the cliff. Here's my cliff, right? The cliff casts a 60-foot shadow. And if we want to find the height of the cliff, we just, again, similar triangles. I see 2 triangles. I see the, well, let's call it the friend triangle, the blue triangle, right? And then let's take a look at the big triangle, which we'll call the cliff triangle, right? So I've got a blue triangle, the little one, and the cliff triangle. Fortunately, we did this in geometry, which makes it pretty easy. So the cliff height goes to the friend height as the cliff shadow goes to the friend shadow. Remember, the same words. So I'm going to go cliff height to friend height. So I'm going to go x goes to 5 as cliff shadow, which is 60, goes to friend shadow, which is 4. Okay? And if I cross multiply or bring up to 5, it's faster. X is equal to 5 times 60 divided by 4. Okay, so what is 5 times 60 divided by 4? 75. That's in terms of feet. Alright, so homework. Let's see. I will leave that with the substitute, you guys, and he's going to let you know what it is. So, thank you. I'll see you tomorrow.